Hello everybody, this is the notes for section 10.7. This is the last section of the chapter. We've been talking about all kinds of circle stuff, properties of circles, angles with the segments in the circles, segment lengths with the circles. The last step is throwing these circles onto the coordinate grid. So we're talking about equations for a circle. Now, this grid here, where the circle is centered at the origin, there's no numbers attached to it. Basically, we just have a radius, okay? Radius r. So, an equation means we should be able to plug in an x and a y value and have it work for that equation. So, what I'm going to do is just draw out a radius to some generic point. Okay, again, we're not counting grid numbers here. This is not at 3, 4. All right, it's generic. So what I'm going to do is draw a radius, and then I'm going to drop a perpendicular to the x-axis. So now, if you think about this coordinate at this point right here, from the origin, you want a certain distance in the x direction, puts you here. Then you go up a certain distance in the y direction, that puts you at your point. This is the radius here. So because this is a right triangle, leg squared plus leg squared equals the hypotenuse squared. Now, this works anywhere. If I draw a radius out to here, draw a perpendicular to the x-axis, still going a certain distance in the x direction, then a certain distance in the y direction, that's still the radius. And so it's still a right triangle. X squared plus y squared equals the hypotenuse squared. Just doing Pythagorean theorem. We can do this anywhere on the circle. And so this really gives us the equation. Notice how these two things right here and right here, they're exactly the same. All right, as long as we're centered at the origin. So that's what this is. The equation for a circle centered at the origin is this equation. All right, x squared plus y squared equals r squared. So if I start applying some numbers to this grid, we got a radius of 5. So this equation would be x, and we are centered at the origin, x squared plus y squared equals the radius squared. So the equation for this circle that's graphed here will be x squared plus y squared equals 25. That will be the equation for this circle. All right, but this equation, it only works when the circle is centered at the origin. If it's not centered at the origin, now we have a different equation. Okay, take a second, hit pause, copy this formula down. What we're looking at is you have a center of the circle at this point, HK. You still have a radius R. So the generic equation is this thing right here. It's x minus h. H was the x coordinate of the center. That quantity is squared plus y minus k. K is the y coordinate of the center. That quantity is squared. That equals the radius squared. All right, so you need to know this equation. This example says write an equation for the circle with center, -2, 3. So all we're doing is just plugging in. This is my h, 3 is my k, 3.8 is my r value. Plug them into this generic. X minus a -2. That quantity is squared plus y minus k. Excuse me. Oops. K is 3. That quantity is being squared. That equals the radius squared. So, we've got to clean this up a little bit. X minus a -2, that's really x plus 2. Quantity squared plus the quantity of y minus 3 squared equals 3.8 squared. No idea. Oops. You can hear the buttons on the calculator. 3.8 squared, enter. 14.44. There is the equation for a circle centered at the point -2, 3 with a radius of 3.8. Okay, for this example, it says the point 8, -1 is on the circle with a center of 4, 2. Write the equation for this circle. So let me get a nice looking grid on here. And zoom out a little bit. Okay, so it's got a center at the point 4, 2. That's right here. The point 8, -1 is on the circle. That's this point. So the question is, write an equation for this circle. All right, so I'm just going to draw a rough sketch. There's our circle. That's a terrible circle. It's centered at the point 4, 2. It's going through the point 8, -1. If I connect the center to that point, because that point is on the circle, there's my radius. All right? So for the equation, because we have the center, we already got most of the equation. X minus 4, quantity squared, plus y minus 2, quantity squared, equals. All we're missing is the radius. Well, the radius is just the distance between these 2 points. So I am going to draw a little right triangle here. Just doing distance formula, but just using the right triangle idea of the distance formula. So to go from an x value of 4 to an x value of 8, that is a distance of 4. To go from a y value of -1 to a y value of 2, that is 3. You do Pythagorean theorem, you get a radius of 5. 5 squared is 25. There's the equation for this circle. Okay. And the last problem is just graphing. To graph a circle, you need to know 2 things. You need to know the center, and you need to know the radius. So, x plus 1, that means the center is really at a -1. Just like that first example we did, this is really x minus a -1. The generic form of the equation is x minus h. So, if you got x plus, you are subtracting a negative. The y-coordinate is y minus 3, so our y-coordinate for the center is 3. So there's our center. The radius in our generic equation, that number was r squared. So 4 is r squared. That means r is 2. So if we go to our grid, we got -1, 3. There is our center. We have a radius of 2. So what I'm going to do is just go horizontal and vertical 2 units away from that center. That puts a point here, puts a point here, puts a point here, and here. There's the circle. Centered at the point, -1, 3, with a radius of 2. And that is all. All right. Have a good night.